Okay, this lesson 6.5 is talking about solving special types of linear systems. All that's really telling you is that you can use any of the three methods that we've learned. So you can either graph the two systems, you can solve by substitution or elimination. So that's all we're practicing for this lesson. So you can pick which method you like the best. But let's look at example 1. And the system that we have is 3x plus 2y equals 10, and then 3x plus 2y equals 2. So looking at these two equations, what system would be the easiest to solve for? Substitution, elimination, or graphing?
Elimination.
It's whatever you like. I mean, I'll go with whatever.
Can I go back to the second before that? Let me check what
Sure,
elimination was.
sure.
Addition, right? You can also use addition.
Which is the elimination method.
Elimination.
Uh-huh.
Yeah, I would say elimination.
Yeah, I would say elimination as well. They actually in the book show you two different methods, but let's just do elimination. So in order to use elimination, what's the one thing we do have to do to this?
Move it around?
No, it's already in the right, it's in standard form. But in order to add, one has to be positive, one has to be negative.
Yeah.
So we need to multiply one of them times a negative 1, right?
Yeah. So
Okay.
it'd be negative 3x.
Yep, so that'd be negative 3x minus 2y equals negative 2, right?
Yeah.
And then I'm going to rewrite the top equation, 3x plus 2y equals 10.
Mm-hmm.
And then we add to do elimination. So what do you notice here? We have 3x, a negative 3x, and a positive 3x, so those cancel.
Yeah.
But then I have a negative 2 and a negative 2y.
So it'd be a 0.
So this would be 0 equals, what's negative 2 plus 10?
8.
8. Can 0 ever equal 8?
No.
No. So then the answer to this equation is actually no solution.
Solution. So when it's a 0, because I've seen like onto this, like there's just 0, I just put no solution.
As long as you come out with something cannot equal another, like you could come out with 3 equals 10, no solution.
Yeah.
You have to, if you came out with 10 equals 10, then that would be all real numbers. Would be the answer, because that means you have a line on top of a line.
Yeah.
Yeah. But if you come out with something that's not plausible, then absolutely, you would say no solution.
Okay.
All right?
Yes, ma'am.
The next one.
So we're just reviewing like the types of ways you could do it.
All right, so then, and we're also going over solution, no solution, many solutions, those things.
Yeah.
X minus 2y equals a negative 4, and then y equals 1/2 x plus 2. Make sure you put this in your journal. Whoop. All right, so first of all, what's the one thing I need to do? Well, what method do you want to use? Do you want to use substitution, elimination, or graphing?
Substitute.
We could do substitution because this one is already solved for y. So we take this whole thing and we plug it in where the y is. So I have x minus 2 times, and then I write this whole thing over here. 1/2 x plus 2 equals negative 4. Okay, so then do the math. I have x, what's negative 2 times 1/2? It's just negative 1x. Negative 2 times 2 would be negative 4.
Negative 4.
All right, and then I add 4. Okay, and then I get 0 equals 0, don't I? Because x minus x cancels. Now, does 0 equal 0?
Yes.
Yes.
So it'd be all real numbers.
So in this case, it would be many solutions. Infinite many solutions. Infinite. And that just basically means whatever number I put in for x, I'm going to get the same number for y. Doesn't matter what number I put. I could put 1,272,000 and it would come out with the same answer for y, because
That's
they're
why it's
they're two
called-
lines on top of each other.
Yeah, that's what it's called, infinite, right?
Correct.
Always gonna be the same.
Literally any number you plug in, it will come out with the exact same answer. Okay, so as a reminder, put this in your journals.
Oh, that graph.
This little chart, yep.
Little chart.
Okay, this helps you remember when you're graphing it or looking at it. If you have one solution, it means they're different slopes. So that means the two lines are going to cross somewhere. I'll draw miniature graphs over here. So on this one, I have this line and this line, and they cross at one point. No solution means they have the same slope but different y-intercepts. So a lot of times you'll see parallel lines, like so. Okay, and then infinite many solutions means you have a line on top of another line.
Oh. Yeah, I do remember that.
Yep, it's just been a little bit. All right, so let's look at example 3.
Oh, that was, yeah.
Yep, example 3. So in example 3, without solving the linear system, you're going to tell whether they have one solution, no solution, or infinitely many solutions. So let's look at A. We have 5x plus y equals negative 2. And we have negative 10x minus 2y equals 4. Do you know off the top of your head, how do you solve without actually solving? I'll give you the hint. The way you solve to figure out is whether the lines are parallel, means they're the same line, right? But they have different y-intercepts. If they're infinitely many solutions, they're the exact same line sitting on top of each other. And if they're one solution, then they have different slopes. All right, so can we put these in y-intercept form and then be able to tell without actually solving the system?
Yeah.
Yeah, so let's put the first one in slope-intercept form. So all we have to do is solve for y. So minus 5x to move it over here. So then I get y equals minus 5x minus 2. So there's my first line. Now let's solve the other one. So I need to move this 10x to the other side, so plus 10x. So I get negative 2y equals 10x plus 4. Now to get the y by itself, what do?
You divide.
Divide by negative 2.
Divide by negative 2.
Yep. Divide everything over there by negative 2. I get y equals negative 10. Sorry, 10 divided by negative 2 is negative 5x.
Yes.
4 divided by negative 2 is negative 2. Now let's look at these two lines. What do you notice?
They're the same.
Exact same lines. So which of those?
Infinitely.
This was,
solutions.
that's right, infinite many. Infinitely many solutions. Cool, and all you had to do was put them in slope-intercept form. You didn't even have to solve the system. Okay, so let's look at B. We have 6x plus 2y equals 3, and 6x plus 2y equals negative 5. Okay, so we could put this in slope-intercept form and see what happens. Or you could look at that and tell me, what do you think?
I think it'd be no solution.
Yes, you're right, because if I rearrange or do elimination method, what happens to my,
It changes.
yeah, it's going to cancel those out, and I'm going to end up with something along the lines of 3 equals negative 5,
Yeah.
which can't happen, so no solution. So sometimes you're not even going to have to put them in slope-intercept form. Now, if I had put them in slope-intercept form, you would have found out that the slope was identical, which would have been negative 3, but the y-intercept would have been different.
Yeah.
Is what you would have figured out. But since they have the same slope and different y-intercepts, there's no solution. They'll never cross.
Yeah.
That means if I were to graph these two lines, they would be parallel lines.
Yeah.
Good. All right. That's it. That's the lesson.
That's it.
That's it. Any questions?
Oh, no. Actually, I do get it. I don't get them all. I do get like the.
Good. You understand them?
Yeah, I understand.
If you look on the back of page 406, the top of page 406,
Yeah.
it shows you the graph versions of that chart. If that's not something you have memorized, I would put that in your journal. But
Yeah.
we've put that in your journal before, so.
Yeah, I already have it in my journal.
Okay, so that's your assignment.
I don't have to graph as long as I get the no graphing, right?
Not unless it specifically tells you graph this.
Oh, okay.
As far as I can tell, there's some graphing. Numbers 8 through 13, you have to graph those. But it's odds, so you only have to do 9, 11, and 13. So you only have to do 3 graphs.
Oh, okay.
And then the rest of it, you can either choose how you want to do it.
So what are the questions we're doing?
5 through 35 odds.